Hi everyone, welcome to video 6 on distance time graphs. This is Ms. Brown. Today we're going to be answering the essential question, how does the shape of a distance time graph describe the motion of an object? The trend line on a distance time graph is really useful because it can tell you nearly everything about the movement of a particular object. For example, it can tell you the direction of motion, whether an object is going forward or backward. It can tell you the velocity of motion, whether an object is going fast or slow. It can tell you whether something is moving for a short amount of time or a long amount of time. And it can also tell you an object's location at any time over an interval. So let's start by figuring out how we can use the trend line to determine the direction an object is moving. Let's start with the orange car that's represented by the orange line. If you look at the lower left-hand corner of the graph, you'll see that the orange car's position starts out at distance of 0 at time 0. So this is where the orange car is starting out. If you put your finger on that line, and as time clicks along, so after 1 second, 2 seconds, 3 seconds, the distance from its original spot, from 0, is increasing in the positive direction. So this car is moving forward with respect to where we have 0. If we now look at the blue car, represented by the blue line, you'll see that the blue car's line intercepts the y-axis right at a distance of 5. So this car is starting out 5 meters away from 0, and as time ticks along in this case, this particular car is getting closer and closer and closer to 0, indicating that the car is moving backwards or back towards 0. Now this doesn't mean the car is actually physically going backwards, it just means it's headed in the backwards direction. It's becoming closer to 0. Let's now look at how we can use distance time trend lines to tell us something about the velocity of an object. Here we have trend lines that represent a red boat, a green boat, and a purple boat. Both the red boat and the green boat are starting out at the same spot at a distance of 0 meters. After 5 seconds, however, the red boat, if you put your finger on the line and follow it all the way across until it's at 5 seconds time, the red boat has only covered a distance of 5 meters in 5 seconds, whereas the green boat in 5 seconds has covered 10 meters. The green boat has covered more distance in the same amount of time as the red boat, so therefore is traveling faster. It has a faster velocity. This also means that the steeper the line on a distance time graph, or the steeper the slope of the trend line, the faster the object must be traveling. If we then look at the purple boat, at time 0, the position of the purple boat is 11 meters away from the origin, or the 0 mark. After 5 seconds ticks along, that purple boat is still at 11 meters away. So the purple boat's position has not changed. Even though 5 seconds has gone by, it has been at 11 meters the entire time, which tells us that that purple boat is stopped. So flat lines on distance time graphs represent stopped objects. So let's talk about acceleration. Accelerating objects are speeding up or slowing down. It's a common misconception that for something to be accelerating, it has to be speeding up, and this is not true. It could be speeding up or slowing down. So how do we know if an object is accelerating? By just looking at the distance time graph? Well, the trend line on the distance time graph that's representing the object will have a slope that will be changing. So this could show a curve or a bend. If the slope is getting steeper, either in positive or negative, the object is speeding up. So the graphs below that show this are, or the trend lines are B and D. If the slope is getting shallower, meaning the steepness of the line is getting shallower, the object has to be slowing down. So graphs A and C show that it started off steep and then it started getting more gradual, shallower slope. If the slope of the trend line is constant, meaning the line is perfectly straight, this means the object is moving at a constant velocity. And things that are traveling at a constant velocity have zero acceleration. They're not speeding up or slowing down. These lines don't have to be flat. It can be a straight line that has a positive slope or a straight line that has a negative slope. It just can't have any bends or curves in it, or else it will be accelerating. So let's use what we've just learned about distance-time graphs and what the trend line means to interpret the motion of this graph of a pink motorcycle. If we look at where the pink trend line starts at the left side of the graph, at time 0 you'll see that it intersects that y-axis right at a position of 5 meters. So this is our starting time and location. Time being 0, starting location being 5 meters away from some designated 0 point. Over the next 7 seconds, as time goes on, that motorcycle is moving in the positive direction, getting farther and farther away from where it started in the positive direction. So at time 7, you could see that that motorcycle is now at a position of 12 meters. Between time 7 to time 8, the position of the motorcycle is not changing. It stays at 12 meters away. And we can tell that by looking at the line. It's a flat line. The distance is not changing at all. It's staying at 12. Then at 8 seconds, the motorcycle starts to go in the opposite direction, backwards, driving in the backward direction, back towards the distance of 0. And because this slope is much steeper than the slope of the first line segment, we know that it's traveling at a faster speed. It's covering a greater distance in a small amount of time, and the ending time and location, after 10 seconds, the motorcycle stops at 2 meters away from 0. So right now, take some time to summarize the notes you've just written, revisit the essential question, and try to answer, how does the shape of a distance-time graph describe the motion of an object?